For this problem, I'll start by treating it as a homogeneous differential equation. It'll be y triple prime minus 3 times y double prime plus 3 times y prime minus y is equal to 0. So the auxiliary equation will be m cubed minus 3 times m squared plus 3 times m minus 1 is equal to 0. I'll try testing possible values for m. One possible value is 1. We'll get 1 cubed minus 3 times 1 squared plus 3 times 1 minus 1 is equal to 0, which would be 1 minus 3 plus 3 minus 1 is equal to 0. These 3's and 1's will cancel, so 0 will be equal to 0. So we know m is equal to 1 is one of our roots. So it'll be m minus 1 times some unknown will be equal to m cubed minus 3 times m squared plus 3 times m minus 1. To find this unknown, all we have to do is divide both sides by m minus 1. So to find the unknown, all we have to do is use long division. We'll divide m cubed minus 3m squared plus 3m minus 1 by m minus 1. The first term will be m squared. Down here, it'll be m cubed minus m squared. We'll get negative 2m squared. We'll bring these down, plus 3m minus 1. So the next term will be minus 2m. We'll get negative 2m squared plus 2m. Again, we'll subtract these. We'll be left with m minus 1. So the last term will be plus 1. And we'll have no remainder. So this unknown was this m squared minus 2m plus 1. So we have m minus 1 times m squared minus 2m plus 1. That will all be equal to 0. This second term factors, 2m minus 1 squared is equal to 0. So because we have m minus 1 times m minus 1 squared, we know that it's actually m minus 1 cubed is equal to 0. So all three roots, m1, m2, and m3, are all equal to 1. So the complementary solution, yc, is going to be in the form c1 times e to the m1x plus c2 times x times e to the m2x plus c3 times x squared times e to the m3x. So yc will be equal to c1 e to the x plus c2 times x times e to the x plus c3 times x squared times e to the x. Now that we've found the complementary solution, we have to find the particular solution. G of x was given as x minus 4e to the x. If you remember, whenever g of x has any x term, in our yp, we have to account for the x as well as the possibility of having a constant. So to account for the x term, we'll have ax plus b. Now to account for this 4e to the x term, ordinarily, it would be some constant times e to the x. However, in our yc, we also have some constant times e to the x, as well as some constant times x times e to the x, and some constant times x squared times e to the x. Normally, when we fix this, we'd multiply with an additional x, but because we already have it up to x squared, we have to have x cubed times our e to the x term, and I'll use a different constant for this. I'll call it d. So yp is going to have ax plus b plus d x cubed e to the x. Now we can take the derivative. Yp prime will be equal to a plus, and for this term, I'll use the product rule. I'll differentiate the e to the x term first. We'll have dx cubed e to the x. And for the second term, I'll differentiate the x cubed term. We'll get 3d x squared e to the x. We can take the derivative again. Yp double prime will be equal to, the derivative of a constant is 0, so that a will be 0. For this next term, I'll use the product rule again. We'll have dx cubed e to the x plus 3d x squared e to the x. For the second term, I'll also use product rule. We'll have plus 3 dx squared e to the x plus 6d x e to the x. Two of these terms will combine, so yp double prime will be equal to d x cubed e to the x plus 6 times d x squared e to the x plus 6 times d times x e to the x. We can take the derivative once more. Yp triple prime will be equal to, for this first term, we'll use product rule again. We'll get d x cubed e to the x plus 3d x squared e to the x. For this next term, it'll be plus 6d x squared e to the x plus 12d x e to the x. And for this last term, it'll be plus 6d x e to the x plus 6d e to the x. we can combine some of these terms. So yp triple prime will be equal to dx cubed e to the x plus 9 dx squared e to the x plus 18 dx e to the x plus 6d e to the x. The original differential equation was given as y triple prime minus 3 times y double prime plus 3 times y prime minus y is equal to x minus 4e to the x. Because yp is the solution to this differential equation, we can plug in yp, yp prime, yp double prime, and yp triple prime into this differential equation. So yp triple prime was dx cubed e to the x plus 9 dx squared e to the x plus 18 dx e to the x plus 6d e to the x. That'll be minus 3 times yp double prime, which was dx cubed e to the x plus 6d x squared e to the x plus 6d x e to the x. Then it'll be plus 3 times yp prime, which was a plus dx cubed e to the x plus 3dx squared e to the x. And lastly, it was minus yp prime, which was ax plus b plus dx cubed e to the x. And that was all equal to x minus 4e to the x. We can distribute some of these terms. We'll get a minus 3 dx cubed e to the x, a minus 18 dx squared e to the x, and a minus 18 dx e to the x. Then from this term, we'll have a plus 3a, a plus 3 times dx cubed e to the x, and a plus 9 dx squared e to the x. And from this last term here, we'll have a minus ax, a minus b, and a minus dx cubed e to the x. Some of these terms will cancel. We have this negative 3 dx cubed e to the x term, and this positive 3 dx cubed e to the x term. They will cancel. We also have this positive 9 dx squared e to the x, this positive 9 dx squared e to the x, and this negative 18 dx squared e to the x. All three of those will cancel. We also have this positive 18 dx e to the x, and this negative 18 dx e to the x. They will cancel. We have this positive dx cubed e to the x, and this negative dx cubed e to the x. Those will also cancel. We're left with this 6d e to the x, this positive 3a, this negative ax, this negative b, and that will all be equal to x minus 4e to the x. We can now compare coefficients. The coefficient of e to the x is 6d on the left, and on the right it's negative 4. So 6d will be equal to negative 4. D will be equal to negative 4 over 6. So d will be equal to negative 2/3. We can now compare coefficients for the x. On the left we have a negative a, and on the right we have a 1. So negative a will be equal to 1, or a will be equal to negative 1. And lastly, we can compare the coefficients of all the constant terms. We have this positive 3a, this negative b on the left, and on the right we have nothing, so it'll be 0. So 3a will be equal to b. A we found was negative 1, so b will be equal to 3 times negative 1, and b will be equal to negative 3. Earlier, we said yb was equal to ax plus b plus dx cubed e to the x. I'll write this using the coefficients we just found. A was negative 1, so yp will be equal to negative x. B was negative 3, so it'll be minus 3. And d was negative 2/3, so it'll be minus 2/3 x cubed e to the x. Now that we found yp, we can use the yc we found earlier, which was c1 e to the x plus c2 times x times e to the x plus c3 times x squared times e to the x. The general solution y is given as yc plus yp. So y will be equal to c1 times e to the x plus c2 times x times e to the x plus c3 times x squared times e to the x plus yp, which was minus x minus 3 minus 2/3 times x cubed e to the x. So that is our final answer. If this video helped you, consider subscribing.